Hello everyone, we are going to talk about analog and digital today and explore digital right. So first thing I'd like you to do is think for just 5 seconds about something that's analog and something that's digital. You can think of something from programming and engineering or art and design or sports or whatever your interests are. Try if you can think of something that's analog and something that's digital. So the ones that come to mind often as an illustration for me are clocks. So we think of an analog clock as sort of an old one you might have seen on the wall, right, where the hands turn just like this, right, or even a non-smartwatch, regular watch. They're turning continuously, and digital clock would be, could be like this, or basically anything on your computer, or your smartphone, something like that. So the world is analog. Things that we live in and perceive as humans is analog. So this is paints blending smoothly together. You take two oil paints, two watercolors, you put them together, they blend in a nice smooth gradient. If you have a violin and you slowly increase the pitch as you move your fingers on the strings, the pitch will increase smoothly, particularly because it's a fretless instrument. So when we say things are analog, we mean that there are infinite variations of these events. So there's the distance between 2 points. You can be halfway there, you could be a third of the way there, you can be 99% of the way there. There's an infinite set of positions between 2 points. Digital is everything that we think of with computers, although digital doesn't just mean computers. It can apply in other places. Digital is discrete. Discrete meaning finite, meaning there is a limited number. Now, it can be a very large number. It can be 10,000. It can be a million, 4 million. It can be a very large number, but it is still there. You could still list them all out if you wanted to, in theory. It's not an infinite number. We think of this, a simple example is binary, right? Binary is a discrete value because it's on or off. You can't be a little bit on or a little bit off. So binary has two states. Often digital values will have more than this. So for example, colors, when you represent colors, colors are a set of R, G, and B, red, green, and blue. And each one of those values varies from 0 to 256. 255, pardon me. So that's three different numbers. There's still a finite number of sets. And so we call this discrete. In a perfect illustration, especially if you think about music, is to look at this graph. So an analog signal, like the clock we showed or paints blending, is a perfectly smooth blend through all of these states. So this would be a sine wave, right? It's going through all of the states. Now, in the digital world, though, we can't infinitely represent states. And the reason actually is because computers don't have infinite memory or infinite processing power or infinite storage to process and store all this data. So everything that's digital in a computer has a finite number of states. Now, as you get better quality computers or better processing, you can have more states. Like for example, the TV standards keep getting better. So you might have had 1080p, and now you have 2K and 4K and 8K. All that means is that the video quality is getting better because the number of states are increasing. So if I look at this graph, if I were to think of my blue line, let's see if I can. If I were to add more states in here, right, I could do that in my digital world and represent more states. But it's still never going to be infinite. And that's the difference between analog and digital. Now what we're going to focus on for now is using digital signals. So when we're going to use the argon, whether we want to send or receive signals, the first thing we have to do is in the setup function, we need to say, is the pin that we want to deal with going to receive or send data? That's all, just one command. So using the pin mode command, we say what is the number you want to, the number of pin you're looking at, and you basically get to then say, is it input or output? And those signals that are coming in or out will then have a high or a low value. And for us, high is typically going to be 3.3 volts. That's what the Argon uses. In some cases, we'll sometimes use 5. It's got more potential, higher voltage. It's the potential that's used for the VUSB, like USB controllers. But typically, this is the one that we're going to focus on. So, question in the slide would be, what examples have we seen of digital output already? Well, turning an LED on and off is a great example of something that's digital, right? So we send the signal to turn the light on to make it high, or turn it off, make it low. So this is the formal way that we're looking about it. When we want to send a value that's digital, we simply use the command digital write. And we specify, again, the pin number. So, D1, D0, whatever it might be. And then you say, do you want it to be high or low? You're writing a digital value. 0, 1, on, off, true, false. That's how you're doing it. Typically, this command could be in loop or setup. It doesn't matter where it goes, depending on what you're needing to do.